Okay, so this short video is to help you to do the final element for this problem. So this is the MATLAB code. I think will be part 3 of the problem. So 0.5, 0.3, 100, 200, and this insulation probably can be modeled by assuming a zero heat flux or a very small value for the heat flux, okay? So let's do it. So you open FEMAP. If you go here, probably you type FEMAP. You should find it within the software. We come over here. We can go to geometry, create surface corners. So let's say 0, 0.5, 0.3, and 0.3. Cancel, Control A, and this gives you this. Model, materials, new. So we don't need to put anything here because we're not going to calculate any deflection. In these problems, we moved all these ones to the right-hand side, so we can just put 1 over here. I don't think you need 1 for this one, but 1 for this one, and this one, they just put it everywhere to be safe. Okay. So now we can go to property, new. This one here, element property plate. Randomly here, we're gonna have 0.1. You could put anything you want, okay? It's not gonna affect the temperature distribution. It will affect, for example, if we look at the conduction throughout the thickness, but this is not a concern of this problem. So cancel. So you can see it here on the tree. Next thing is to do create the mesh. So whatever, let's do it square if you want. So you can do size along curve. So whatever, let's do it. I don't know if it's gonna be too much or not enough. Let's do 60 over here. And here, 5, 6, 60. That looks okay. And here, let's do 60 as well. So that will be a lot smaller. Maybe we'd like to have the reverse. All right, let's add some more over here. Let's put over here 80. Okay, it doesn't matter really what you put. It's just like that. So now we can go to mesh, geometry, surface. Okay, should ask us the property. We use the plate. Okay, so this is pretty refined. The reason I'm doing refine is because we need to find what is really the temperature as close as we can of these edges. So we could even go smaller, but for this video, I think should be enough representation. So now we go model, load. We can do on curve. Let me go back to the problem. So 100, 200, okay. So let's say over here, let's say boundary if you want. But you don't have to type anything if you don't want. So let's see this edge over here, that curve, we can put the temperature to be 100. And this one over here, the temperature to be 200. Now we can select these 2 curves over here. So I saw before you have here the heat flux. I was surprised that it lets you put 0. So they just put a very small value. Okay, compare this one here. Okay. Let's save the model, file, save as. So yesterday I was playing a bit with it, so I think semester is for assignment 3. Let's got this one, model 2. Save. Now you can go here to the little wheel or gear. So here, right click on analysis, manage, new. Here you see different type of solutions. Go and select steady state heat transfer. Okay. And click Analyze. And here on the left screen, you should see what is the progress. So it looks like it's finished over here. You can close this one. Open here the results, all results. So case one. Click on F5. Contour over here. Deform. We want to look at the temperatures. Okay. Okay, so this will give you the temperature distribution. You want to remove the nodes, I think you can click. You can remove this one. You can look at this at different forms, I think. Oops, that's the value. This is the contour. But you can even remove if you want the mesh over here. Okay. You can play here with the view. Okay. But here, let's find out what is the temperature along this edge, for example. So probably you can just go here and do F5 criteria, and it's going to be hard to look at it. If you press Control and then the middle button in the mouse, you can move this one. Then you can roll. You can zoom over here. But I mean, this is very inconvenient over here. So probably the best way, do Control A to recenter. Click over here again to remove these ones. And what I'm going to do here is actually to create a group. So let's say right edge. Okay. Now I go here to group, nodes, ID, pick, box. Oops, they're not selected, so I don't know if it's going to select them or not. Let's see over here. Yeah, selected all the nodes over here at the end. Okay. So now you go to the group over here. Show full model. You can say show active group. Deactivated the nodes, so maybe I need to reput them. We see them over here. And now you can just come up here, do F5 criteria. Okay, F5 criteria. All right, let's see what happened here. Okay, so maybe we need to put the elements as well. So group, elements, ID, pick, box. Again, make sure you only select the first ones over here. Okay. Right click on the group, show active group. Okay, so we needed also to select. If you click Control A, now you can see the different temperatures over here. I mean, you can take one by one and do the average. But let's see, I remember this was pretty helpful. List, output, result to Excel. Click custom. Okay. The temperatures. Okay. And select the nodes, pick box. You select all these ones. Okay. Okay. So it should create an Excel file over here. You see this one over here. So blah, blah, blah. You could come to this one over here, for example, and type over here equal average. What is this? F2 to F62. Okay, so that gives you, let's say, 188.275. Okay, so the temperature, the average temperature on this edge would be 187.25. We can do the same thing for the top one. So Control A, maybe go to groups, new, top edge. Okay, the one might be a bit more difficult. So let's see. Group elements ID, pick box. You see I pick outside. And now I'll go to the other corner. I'm going to select just these ones here. Okay. Group nodes ID, pick box. I do the same. Okay. So top H, show active group, and I can do the same thing with list, output, results to Excel, customs. Okay. Temperatures. Okay. Pick box. Hopefully it's going to create a new file and it's not going to add it to the other one. Okay. So all right, so we created here something. I don't know which one is. Okay, so you see that one's go from 144. All right, so it's the same thing as before. We could go over here. Average F, let me put F2 to F82. Equal 155.78. So now we know that for the top H would be 157.28. Full model, F5, contour. And now when you do the analytical solution, instead of using here the insulator, just put those two average temperatures, so the 187.28 and the one, let's see, 157.58 for the top, and 1.88.275 for this right H. And then, yes, you can find now the analytical solution for these cases, okay? And then once you have the analytical solution, plot the, that would be part 4, which is what I put over here. I want you to plot in MATLAB what will be the temperature distribution and compare it to the FEMAP one, okay? On this section over here. And you can also compare it to your final difference solution. So I hope this video is going to help you.